There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron.
What is this? The Green Porno experiment! If I was Ernest Rutherford, I would discover many things, in more ways than one. I would discover that an atom has a positively charged nucleus and negatively charged electrons surrounding it. It is made of mostly empty space, with most of its mass at the nucleus. My gold foil experiment can be used to explain this. The electrons surround the nucleus in a three-dimensional figure. First, I would obtain a piece of gold foil and a particle emitter. I would set up a screen that is covered in zinc sulfide. The emitter will fire the alpha particles. Pew! Pew! Oh, look, a deflection. 1 in every 20,000 particles will deflect. This is true. This experiment was done in complete darkness. My eyes adjust to the darkness. I can see the flashes of light as the particles hit the screen. I will measure the angles between them. The nucleus is 10,000 times smaller than the atom.
I am Neil Bohr, and I will use this experiment to make my model.
Americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium.
What are they trying to bond with me? What am I, fluorine? If I were fluorine, I would be so sexy. I would have the highest electronegativity of any element. That is my ability to attract and bond with electrons. All the elements want to bond with me, even the noble gases. You can find me on the periodic table of elements. You found me! The table is arranged with groups going down the table and periods going across. The atomic radius is the distance between the nucleus and the valence electrons. It increases down a group and decreases across a period. My atomic radius is smaller than that of lithium, who is across period 2. It is also smaller than bromine, who is down group 17. Look at this body, and look at these fatties. Electron affinity is the energy that comes when an electron is added to an atom. It decreases down a group and increases across a period. My electron affinity is larger than that of lithium and bromine. My electron affinity is so high, no wonder all the other elements want me. Ionization energy is how much energy is used in the removal of an electron from an atom. It decreases down a group and increases across a period. My ionization energy is higher than that of both lithium and bromine. I give my electrons away to everyone.
Thulium and thallium. There's yttrium, ytterbium, actinium, rubidium, boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium.
What, are we switching partners? What, are we a metathesis reaction? If I were a cation, I would have a positive charge and be attracted to anions, or negatively charged ions. In a precipitation metathesis reaction, I would start with one partner, but as time goes on, I grow tired of him. So I would react and join a new partner of opposite charge. We would be too close to separate, and and we would form a solid together, while the others are soluble in water and will break apart. Someone woke up on the wrong side of the reaction arrow.
There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercurium, molybdenum, magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, kryptonium, and radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.